Welcome back again, folks. Today we're going to have a look at this Fluke digital multimeter here. It's a benchtop meter. It's a model 8050A, and it's got a little bit of a problem. It came to me pretty much in this condition as a basket case. But you can see the problem down here. If you look at the display, that wand should not be lit at this point in time, because I'm only feeding in 9.6 volts. So it's reading 19, and that's because it's not out of calibration. It's because that wand is on when it shouldn't be. And we're going to look and see why that is and try to replace it. And to help me do this, I'm going to use the tools out of my beginner's toolkit, including the little power supply here, which is giving us that 9.7 volts. I've still yet to do a full test of that power supply, but we're going to use it today anyway. And the screwdriver set's over there, and I'll be using the soldering iron to desolder any chips that need to desolder and resolder in new ones, and get this meter fixed up. Okay, let me show you a little bit closer what exactly the problem is. Okay, I hope you can see this the way I can. I've got a little light shining on the side here to provide a little bit more contrast on the LCD display. But let me turn this voltage up here and have the voltage in backwards so you can see that the negative sign is lit right now. But you can see as I turn the voltage up a little bit to go over 10 volts, see the wand comes on properly and the minus sign goes away. It shouldn't be going away. This is leading me to believe that the right data is getting to the display, but one of the drivers is not driving things properly. Okay, so I hope you can see that problem there. Now, what I think is going on is that one of the drivers has just gone dead or misbehaving, and if we replace that driver chip, this meter should be okay again. Now, I'm not 100% sure of this, but we're going to find out together. So let's now have a look at the schematic, and I'll show you which chip that I need to take out. So here's the schematic, and you can see that this chip here is the one responsible for the plus minus sign and the 1 digit, which is the half digit at the leftmost on the display, and it's the one that's giving us problems. And that chip is U11. Now we can see from the layout diagram here that U11 is this chip right here, or on the board. That's that one right there. So let's have a look on the scope and see what kind of signals we're getting out of that, and we'll go from there. Now, if we probe the output of that chip, specifically pin 3, we can see that we're getting this waveform. It is particularly unusual. This is the kind of waveform we should be getting on any of the output pins. What's more, if I go down here to pin 6, which is the output pin for the digit 1, I can see there's nothing on there at all. And then as I increase the voltage over 10 volts, it just goes straight down. It's not pulsing properly. You can see it's attempting to pulse, but it's not being able to draw the voltage back to 0 again, except for when you see these little pulses that come by randomly there. Those pulses are actually select pulses. When that select pulse goes high, it's when this chip is supposed to receive data, and then it's supposed to output it. But when it outputs it, it should be looking like that. So I'm going to remove that chip and replace it. The chips that I have to replace it with, though, I'm not 100% sure about them. I got them online at eBay. They could be bad, they could be good, they could be fake. We'll find out. So we're going to remove that chip, and in order to do that, I've got to take this board and separate it from the rest of the meter. It's pretty easy to do with these things. This ribbon cable here is just clamped down with this bar. So if I remove the 2 screws from this bar here, we should be able to get the put a little bit more light on the situation here. Should be able to get that board separated fairly easily. Yeah, just like that. Let's get this off to the side here. Move some stuff out of our way, give ourselves some room. And what I'm going to do to get that chip out is I don't want to take any chances in ruining this board. I can't get a board to replace it. So what I'm going to do is I'm actually going to cut each of the pins around the chip. Then I'm going to remove each pin separately and clean out the whole solder sucker and put the new chip in and solder it back in. So let's get started on that. All right, I'm going to use these flush cutters here. I'll cut each pin one by one. Also, please forgive the noise in here. It's we've got quite a bit of equipment in here running right now. I've got some other stuff to do later, and I need to warm the equipment up so that it works its best. You usually hear some noise like that in the background of my videos. I wonder if you can see this all okay. The light is at a premium around here. Hold on a second, let me see if I can improve that. There, hopefully that a little bit better. We'll continue removing these pins from the chip. That's it, the chip is out. So now what we'll do is we'll I'm going to prop this up on something, and in fact I'll use a board holder, and we'll remove those pins one by one using our kit soldering iron and the solder sucker. These are the chips that I got to replace it with. So they look okay to me. We'll put one in and find out. Okay, that was a bit more delicate an operation than I had hoped. These traces are not very well stuck down to the board at all. So I had to be very, very, very careful. Let's just clean up a little isopropyl alcohol. Back here. Definitely not a job for the faint of heart. You can see that right here on pin 4 and pin 6 of the IC, actually the pads on this side came off. Now they're not that important because there's nothing attached to them on this side. The plated through holes are okay, and the important pads, lands on this side, are fine. And yeah, hopefully we didn't do any serious damage to it, and hopefully we actually made it a bit better. A little bit more isopropyl here to okay, we're going to let that dry off and hook it back up, and well, we'll see where we are then. Connect our ribbon cable. I guess this is the moment of truth. liking what I'm seeing. Perfect. So let me set up the camera so you guys can see what I'm seeing, and I think we've got a working meter now. There we go. That's looking a heck of a lot better. So we'll turn up the voltage to get the half digit to come on, or the leftmost one. And whammo, there it is. So it needs to be on, it's on. It needs to be off, it's off. We'll also change the polarity here. See if the plus sign comes on, and yes it does. And does the wand still work? Yes it does. Fantastic. We now have a fully functional Fluke 8050A. Now let's put it all back together again, and we're going to compare it a little bit with the Siglent digital multimeter, the 3055 that we have on the bench here. Now let me set up for that. There, we're all screwed. Now the backs go on these really easy. It's just a single screw at the back, and that's this big long one. I recognize those. Look at the case on it. Just like this. There we go. The screw in the back of it. Looks like this had a sticker on it at one time. Okay, we're not going to be doing a calibration adjustment here. We're just going to look at whether or not the meter needs calibration, or is it fit for use as is. A couple of things should be considered in doing this. First, my use of this will never involve higher voltages, so I'm not concerned about the accuracy of the highest ranges. Second, the way these meters work, everything is based upon voltage references and precision dividers. So if you look at one of the ranges, it's dependent upon the other. So for instance, if you look at the resistance ranges, if the resistance ranges are all okay, and that's an indication also that the DC ranges are okay as well. And if the DC voltages are okay, then the DC current is going to be okay. So you only have to look at a few things. So what we're going to do, we're going to concentrate. We're going to use this little resistance box that we created the other day on the last video, and we're going to concentrate on running down through that. And then I'm just going to go quickly look at a couple of DC voltage ranges, just 3 of them, and a couple of AC ranges, and then we'll check out the diodes, the ability for it to check diodes. So let's get started here. Now, I've used the published specifications of this meter and the values that we have here that we calibrated on this to come up with the ranges that are acceptable. So for this first one, for that first resistor there, that 1.053, so anything between 1.01 and 1.09 on the meter would be acceptable. So let's see what we get there. Okay, 1.06. Well, that's definitely right in the middle of that range, so that's delighted with that. Let's go on up the next one. We'll also do this on the same range, this 100 ohm resistor, because we're still on the 200 ohm range. So anything from 99.86 to 100.14, and again we're smack dab in the middle of that range. So that's great. Things are looking really good. Now we're going to go up to the next range on it, the 2K range. We'll measure this resistor. Now this should come in between 0.9986K and 1.0010. So yeah, we're right in the middle of that range too. So far this meter is looking fantastic for a meter that's old enough to be a father itself. It's doing pretty good. This one should be between 9.993K and 10.007K. We're down near the lower end of that, but I'm happy with that. That's good. You know, we could wait a little bit longer. What'll happen is it does put a little slight bit of current across this resistor. Now this resistor is a metal film resistor, so it's not going to change that much with temperature, but you know, generally speaking, the longer we leave it here, the higher that reading is going to rise. But this is good enough. We're within specification. Now this next range here, we'll check two ranges with this resistor value. So this one here should be between 100.05K and 100.19K, and yeah, we're doing good there. We're in the middle of that range too. Now if we go up to the next highest range, this same resistor should read 99.6 to 100.7, and yeah, we're in the middle of that range too. Now the final one, check the highest ohms range here. This should read between 9.805 and 10.365, and there we are, right in the middle of that range as well. The next thing we're going to do is we're going to look at the 200 millivolt range. Fluke recommend using 190 millivolts to check it out. So here we got 189 point. We're close enough. There it goes. So my voltage reference is not quite stable. I've yet to build a really good voltage reference, but I'm just using a power supply over here. But you can see that the Fluke and the Siglent are in agreement. I mean, within a couple of counts, we're right on. So I'm happy with that. We're going to do the 2-volt range. The Fluke recommend we check with 1.9000. So we are roughly there. Just that little bit. Yeah, so we got 1.9000. We have an extra digit on the Siglent, but that doesn't matter. And yeah, we're within 2 counts on the Fluke, so that's well within specification. Now I also want to check the 200 volt range, but Fluke recommend 190 volts. I don't have 190 volts, so what I'm going to do is I'm going to set up my power supply over here to run about 60 volts, and yeah, we'll try to get it up to 60 volts, and then we compare it with the Siglent to the Fluke. Okay, we got it on the 200 volt range here. We got 59.997 volts going in, and we're reading 59.98. So a little bit of fluctuation here and there, but the readings generally within a couple of counts. So yeah, this meter is perfectly usable. But just for the fun of it, we're going to have a look at a couple of AC voltages and see what they come out as. Okay, so we're set up here. We're using this this signal generator right up here to provide us with 1.9002 volts RMS at 200 hertz. And on the meter down here on the Fluke, we're getting 1.017, which is again well within the stated specifications. So now we'll go up. We'll try to see if we can get as close as we can. For the 20 volt range, which is the other one they suggest you use for calibration, they want you to use 19.000 volts at 10 kilohertz. Now, I don't think I can get 19 volts, but we'll get as high as we can, and but we will be able to get the frequency. Okay, here we've got our generator giving us 7.010 volts AC, and the Fluke is coming up 6.999. So that's within 10 millivolts. I'm happy with that on the 20 volt scale. That's also within the specification of the meter. So yeah, this has been great so far. I'd say a quick look at some diodes to see if we can read diodes and how far we can go with the diodes. Keep in mind though, I mean that this meter dates back to a time when LEDs weren't really a thing yet. I mean they were around of course and they were used, but they were generally used in high-end equipment and stuff like that. And I guess this meter probably wasn't designed to be able to check LEDs, but we'll find out. Okay, so it's yeah, we got it on the Schottky diode here, and it's measuring 2.57. It's fine enough. It's obviously putting very little current across that diode, which is, I guess that's good, but you'll tend to get a very low reading for the forward voltage with such low current. So we'll check the silicon diode out. 0.71. Yeah, that's great. Now let's try the LED. So even the red LED, it'll light it up, but the meter won't give us a reading on it. Let's see if we went up to, no. Needless to say, it's not going to do the amber or the green or the blue, but it lights them all up. So if the amber's a bit dim. So it's good for checking regular diodes, Schottky diodes, germanium diodes, silicon diodes, rectifiers and stuff like that. And it's right around where we'd expect it to be. So yeah. So this meter is perfect. I'm going to use it the way it is. I'll check the calibration in a year or so, and maybe I'll do a full calibration at that point in time. But for me right now, this meter is perfectly serviceable, and for what I paid for it, I think I got it as a basket case. It was, I think, about $35 Canadian, if I remember correctly. And honestly, I don't think there's any kind of meter you can get for $35 Canadian that will match this in performance. It's a great bench multimeter at 4.5 digits. It's got you could set it up so that the AC ranges have different impedances. You just have to go inside and set up the jumpers the way you want it. You have a relative mode here, so you can take a relative reading compared to from one to the next. So we have a relative difference of 0.46 volts between the silicon diode and the germanium diode. So yeah, I mean, like you don't get these features on a $35 meter. So what's that? $35 is what? Maybe about $28 US. So yeah, and all I had to do is I replaced a $1 IC in it, and it took me very little time to do that. So yeah, I'm quite chuffed with this. If you get the opportunity to get something like this and work on it to get it fixed, or even get one that's working, I've seen these go for as little as about $50 US for one in perfect working condition. And you'd be hard put to find a bench meter for that kind of price. And it's a very nice form factor too. It's very stackable. You put stacked up stuff up on top of it, which is important for a bench meter. Like I've seen a few meters these days, like the OON meter. It's a nice little meter. It's a 4.5 digit meter. It's got a much bigger display with backlighting and stuff like that. It's an OLED display actually. But it's a chunky little thing that you can't stack anything on. Like it's higher than it is deep, and it uses up a heck of a lot. It's just as wide as this. It's about that high, and it uses up a heck of a lot more bench space because you can't stack anything on it. I mean, I can stack 2 or 3 of these meters high, or I can stack a power supply on top of this, or a function generator, or something of that nature. Like it fits well into a lab environment. I mean, Fluke weren't fooling around when they built this thing. They designed it for a specific purpose, and it meets that purpose very well. So thumbs up on this one. I'm really chuffed about this meter. It's going to work out very well for my purposes. And thank you guys for coming and watching my video and spending some time with me. We'll see you in the next one. Bye-bye.